We shall start within next 2-3 minutes.
Yeah.
मला असं वाटतं आपण सुरू करूया.
Okay. Okay. I think Vinay has not yet joined.
He's having some problem in joining.
Okay.
So by that time we can start.
Okay. Let me introduce myself. Okay.
Yeah. Welcome all the participants for today's yet another session on behalf of Pune Management Association. I welcome Mr. Nandakumarji Valve, who is the resource person for today evening. He'll be discussing about GD&T and its effect on the cost reduction. I also welcome each one of the participants for this technical session, technical webinar. Let me say something about Pune Management Association. Many of you are the regular visitor or regular attendees of the webinars. In fact, we have already crossed 200 numbers post-COVID. 200 webinars we could conduct with your help, your participation, your support post-COVID, as I said. So on behalf of Pune Management Association, it's my duty to thank each one of you. Pune Management Association, as you are aware, was started informally way back in 1965 by the top industrialist of that time, late Padma Bhushan Chandrarao Ji Kirloskar, late Dr. Nilkantrao Ji Kalyani, late Chandrakant Ji Kirloskar, late Mr. V.S. Vaidya, and late Mr. C.V. Zog. These stalwarts came together and formed Pune Management Association informally way back in 1965. Initially, we started working from Bank of Maharashtra, Bajora Road, and then subsequently in 1972 we shifted to our existing place, Institution of Engineers building. Since 1972 we were there. In 1977 we were formally established as the charitable trust for the promotion of management principles. The mission that time was taken as the promotion principles of scientific management. This was the mission taken by the that times you can say executive committee of the Pune Management Association. Of course, all stalwarts were involved. Uh, then last 2 years we have changed the modality of working of our Pune Management Association. We have established 14 verticals through which we are operating at the moment. Uh, we established verticals for various topics under the management, various subjects, subtopics, sub-subjects under the management, starting from HR to marketing. Each and every aspect was covered under these 14 verticals. So today's program is being organized by one of these verticals, quality. So this program obviously relates to the technical fields in the quality. Uh, More than one point, I think I must highlight that more than literally 100 volunteers are working through these verticals. And though I say volunteers, sometimes it is misunderstood. But all these volunteers are professionally qualified and established people. If you see the list of volunteers working, list of volunteers leading these 14 verticals, most of them are either directors or CEOs or general managers in their own companies or in their own establishment, and they are voluntarily side by side working as the uh, mm, for the benefit of youngsters, young professionals. Uh, Basically, we call it as a joy of giving back to the society. Really, we all these hundreds of volunteers enjoy the joy of giving back to the society. We have practically all these volunteers have established themselves in their field, they're expert in their respective fields, and now they want to give back to the society through this uh, August organization, Pune Management Association. So with this brief introduction, uh, I think Mr. Vinay Kelkar, the moderator, has joined. So before I hand it over to him, I make an appeal to all the participants who are there today to please join Pune Management Association. All the details are there in our website, www.punemanagement.org.in. So you can visit our website, you can see the programs, you can see the details, you can see the details of membership also. And I encourage you to join Pune Management Association so that other benefits are also can be extended to you. Now, with this brief introduction, I hand over to Mr. Vinay Kelkar, who will be moderating today's show. Thank you. Mr. Vinay, please introduce today's guest.
I think yeah, Mr. Nandakumar was always the engineer by profession. He has worked with Mahindra for many in various capacities, including the in charge of quality and
your voice is not audible.
Field.
Slightly louder.
It's on. I don't know.
Voice is on mute now.
I'll just increase the volume. No, not on mute. It's clear. Is it audible now?
Yeah.
Hello.
Yes, it is audible. Yeah, it is audible. Yeah.
So, yeah, I welcome Mr. Nandakumar for the session on geometry dimensioning and topology. It's an important field for various products. Parts of it. So, how is geometry dimensioning and things engineering field related or mentioning and tolerancing will be Eka Kumar Walve. And of course, this also helps in standard dimensioning, tolerancing of our various drawings and details. Helps in cost reduction by giving you suitable input in terms of what tolerances should be adopted for various assemblies or parts. It also improves the manufacturing process. It may also lead to in related tolerances so that manufacturer, the producer, can have better control on it. To introduce this session and start this session is basically with a background, having experience in automotive industry of Mahindra & Mahindra, including the tractors and other equipments. So I'm sorry.
Hello. Yeah. Hello. Yeah. Thank you, Vinayji. Am I audible? Hello.
Yes, sir. Yes, sir.
Yeah. Thanks. Thank you, Mr. Pradeep ji and Vinay ji, and thanks for the nice introduction. There was a little bit issue in voice quality. I hope my voice is audible clearly. So basically, as Pradeep ji said, so this program is organized by the quality vertical of PMA, that is Center of Excellence Quality and EHS. And myself, I'm leading this team, particularly quality vertical. And as you are aware, these programs, various types of programs are conducted. So this is about a fourth program webinar we are going to conduct. So today's topic is GD&T, geometric dimensioning and tolerancing. So today's topic is too much technical, but I am going to try it and make it simple for everybody. Those who are working in industry, mechanical and production industry, basically automobile or component making industry or aerospace industry, how this geometric dimensioning and tolerancing is important part of this industry, but many times it has been neglected because of ignorance. So I would like to emphasize on this point, how it helps for the communication in industry, as well as how it helps basically the cost reduction of in the manufacturing process. Basically, this point is many times neglected, and people are less aware about how it helps to reduce the cost. But rather, many times there is a myth that if you go by GD&T, there is a cost of the product will increase, because looking at the various symbols on the drawing, people many people feels that it is too much technical and too much stringent tolerance are being given, but rather the situation is vice versa. Basically, more and more tolerance is assigned because of this language or GD&T system over our current coordinate system. So I'll just open the presentation now. Just wait for 1 minute. Yeah, is this slide is visible? Can anybody
Yes, sir. Yeah.
Yeah. Thanks. So, today's topic is GD&T, geometric dimensioning and tolerancing.
Slide is
And
not
I'm going to
slide is opening just now.
yeah. Is it open now?
No, not yet.
Now it is visible.
You have to
It's visible. It's
pin
visible.
the PPT rather than pinning Mr. Nandakumar.
No, it is in PPT form only.
It is visible.
It is visible. You have
Those who are
to
not
pin,
able to.
no, you have to pin unpin main person's photo.
It is moving.
Yes, yes, yes.
Yes.
Thanks. I'll now proceed. So today's topic, though it is too much technical, I am going to focus on its importance, how it is important from cost reduction point of view. So if you see it in today's scenario in the industry, many times parts are made in India, in Chennai, Bangalore, or Pune, and those parts are sent to China for making sub-assembly, and the same sub-assembly is sent to US at Detroit for assembling on the vehicle. So if you see this in today's scenario in manufacturing, particular automobile or any other part, because of cost and competition and quality, so it's various in countries, the total product is step by step it is being manufactured. Some child parts are made at one place, sub assembly is made on other place, and final vehicle will be manufactured maybe in South Korea, US, or any other place. So in such case, what is the how communication happens? The communication, though the countries, if you see in the slide, the Japanese, Russian, Chinese, those languages are so uh, complicated for us, because even they are feeling very complex in English, understanding English, they are finding difficulties. Then how these parts are manufactured? The only one language which is common, and that is geometric dimension tensor. This is an engineer's language, we call it as a engineer's language. Though your country language is different, maybe Chinese, maybe English, maybe any other language, but all engineers on the globe are following or understanding this language, that is GD&T. Basically, if you see the part drawings are released by the designers. Particularly, product design is completed by the design engineers, but that is not enough unless and until it is made, manufactured, checked, inspected, and then it is dispatched to the customer as an end user, and he will use it. So during this process, basically designer is communicating the what he wants on the design, or what the performance is required, or whatever customer expectations are there. Those are uh, those he convert it in the drawing form, part drawing form, and then this part drawing is released to the industry for manufacturing purpose. So if you see uh, particularly this language, uh, it has to be understood by all those who are following, those who are referring the part drawing, and also those are who are from the production side, those who are making the parts, those who are checking the parts, those who are doing process plan the parts, like process engineers, manufacturing engineers, those who make the process sheet. Everybody must know this language, that is GD&T. Otherwise, they will not able to understand what is in designer's mind. They will not able to produce the part right, what is required as per the specification, and the quality people cannot check the part uh, as per the specification if it is not produced and if it is not understood properly. So GD&T is the common language followed by all functions and all countries, and it is basically there is a manual is released by SME, that is Y14.5, and recently in 2018 they have upgraded the standard. If you see the bottom portion of this slide, there are many symbols. So like our when we talk Marathi or Hindi, the script name is Devanagari. So similarly, GD&T has its own script, and there are 14 symbols main core symbols, and there are supporting many other symbols are there. And with these symbols, particularly designer communicates to the production people, and production people manufacture the drawing as per manufacture the part as per part drawing, and the quality people check the parts as per the part drawing. So we'll go through this how it is important to these three functions. So particularly this GD&T language is aligning these three functions: design, production, and inspection. So in any product development system, designer make the design either in 3D form or 2D form, and that design is assigned with various symbols so that it will meet the specification, and the design will perform as per the customer's expectation. And this design, when it is released to or many suppliers are getting 2D drawings. On these drawings, the suppliers or from production people refer that drawing, and process engineers also refer this drawing, make the process sheet, and this process sheet along with the drawing, production people use it in refer it in production and make the parts as per the requirement, as per the steps given in the process sheet. And as well as they ensure that while producing the part, the intent of design is met and it is specification is met. And afterwards, once it is ready, the quality people inspect it as per the part drawing. So the part drawing is nothing but the Bible for these three functions. So they must understand this Bible clearly, and there should not be any ambiguity. And this communication is happens through the. So GD&T is so much important language. Everybody must understand. Even in today, many people they go for studying the softwares to release the design, but that is not enough. Software will help you to make the design, but to make the design manufacturable, and to make the design manufacturable, and it should be it should meet the customer's requirement. This language add these symbols, squareness, parallelism, whatever is required, it has been documented on this part drawing. So let us see how it is important and how it reduces. So it is a simple the slide number 4. We are on slide number 4. There are two drawings of the same parts. Child part is shown on the left side. If you see, there is a drawing of simple plate. Two counter bore or holes are there, and there is a lot of essays has been written on left side and right side of the drawing. A lot of text is given on left side and right side at the bottom. So these notes this is a traditional drawing where we follow the coordinate system. When XY distance is given, that is a coordinate system. So basically, understanding this essay, there is always chance that there is an ambiguity for understanding the text, and basically it is always complex and nobody will read it. If you do not read it carefully, there will be a different meaning, or sometimes people miss anything, there will be different meaning, and there is always there is always some error in while manufacturing the part, while checking the part and producing the part. So this all whatever design want to say, which is written in the text form, is completely converted in the symbolic form. That is, if you see the right hand side drawing, same drawing is released through by following the GD&T symbol, GD&T control frames, and exactly whatever is required, it is only given on the drawing. So it is become a neat and clean drawing from appearance perspective. We'll see the intent of this, but as a overall, there is a very less text you will see, very less minimum notes will be seen, which will help us to understand properly the proper requirement, and there will not be any ambiguity for understanding the grammar and text in the drawing. So this is the first advantage, and which will reduce the ambiguity among production, quality, and designer. So many times you will find there is a conflict based on the drawing, understanding the drawing, when the parts are checked in metrology and when it is rejected. So production people run and come to the metrology and they start fighting with the quality people why it has been rejected. So there is always a fight for, because of some ignorance, some misunderstanding. Then they have to call the designer ultimately, then to decide as a jury who is right and who is wrong. So ultimately everybody's time is wasted and resource is wasted. So now with this GD&T, if everybody understands properly in minimum words, minimum symbols, lot of things are explained here. So we'll see one by one. So basically, we are today going to talk about only benefits. We are not going into too much technical, but little bit technical is required to understand the concept of this GD&T. So there are 4 benefits we are going to see. First is which eliminates ambiguity. Second is we get more tolerance for the production more than specification. If specification is given say plus minus 0.1 tolerance, but more than that tolerance is available if we use GD&T. Of course, the GD&T focuses on will not so functionality. The focus is on functionality of part, not just dimension. So that is the intent of the GD&T. Then third benefit is the bonus tolerance beyond specification. So apart from this, you get additional tolerance, which we'll see how the bonus is getting. So that is why, which is additional tolerance. That is why it is we call it as a bonus tolerance. And then inspection, easy for inspection by making the functional gauges. So this reduces the inspection cost of in the process. So all these 4 points, if you club together in terms of money, so you will find a lot of saving will be there because of more tolerance. Additional parts got accepted. There is because of less ambiguity, rejected part will not get accepted, and accepted part vice versa. Accepted part will not get rejected in the during the process. So because of bonus tolerance, additional more wide tolerance is available than in the drawing. And of course, inspection cost will reduce, because if you today's scenario, you know the CMM cost. The CMM cost is 1,000-1,200 per hour. So and lot of skill is required. So this cost, it can be reduced by just making simple functional gauges. So of course there are some limitations are there, but most of the time it is possible to provide the gauges at the end of the line, so that any unskilled worker or labor can check those gauges with simple SOPs. So that is the advantage, which also labor cost will and inspection cost will reduce. So we'll see one by one. So first is the eliminates ambiguity, which stops wastage of okay parts and acceptance of rejected parts. So let us see a simple drawing. So I'm not making it complicated. In old traditional drawings, generally people are writing like this, or designers. Surface A and B are perpendicular to each other within 50 micron. Just these notes indicates that two faces of this simple rectangular block should be 90° to each other. So face A and face B should be 90° to each other. This is the requirement. It is written in the text. So how it creates an issue, let us see. So when we produce these thousands of parts and it comes to the receiving inspection, what happens? So how it has to be inspected? So then there is a question. The person who is going to inspect, he will keep the job either vertical or horizontal. So definitely whichever is easy for holding the job, he prefers that, because nothing is given in the drawing whether I should rest it on A face or I should rest it on B face. So what happens in such situation? So he has to inspect like this. the moving the dial up and down. So moving the dial up and down, it will check whether it is in 50 micron or less or more, and he will decide the job whether it is accepted or rejected. So what will happen in such situation? Some people will follow method A, some people will follow method B. Then definitely there is always chance that many okay job required will get rejected, and sometimes rejected job will get accepted. In this case, what will happen? On the right side and left side, both are showing the reading 50 micron, which is acceptable. But if you see the left side job is more, method A is a job is very accurate, because the length of the job on which we are checking 50 micron is almost 3 times than this horizontal job. So what will happen? You will get more accurate job, more closer to the 90 degree if you follow the method A. But if you follow the method B, you will get more wider job which are away from 90 degree for the same reading. So this will create ambiguity, because the person who is checking doesn't know how the part is going on assembly, whether horizontal or vertical. So he will definitely follow, either supplier or quality person, anybody who is in the production will follow the simple method, and there is no consistency whether A method will be followed or B method. So this ambiguity. So in this case, if you see, the angular deviation alpha is very much less than the angular deviation beta. So both parts are same. Either check vertically or horizontally, you will get different reading. So many times it happens in metrology. If you change the reference surface, you will get different reading. So same thing will happen here, because nobody knows whether I should rest the part on A or B. So this ambiguity is eliminated by this language GD&T over the coordinate system. So it's the same job. If you see, same job, if you tilt is, you will get different reading, and if you keep it vertical, you will get different reading. And the same job, either it will get okay job will get rejected, or not okay job will get accepted. So this is again the loss to the company, loss to the everybody, and unnecessary cost will increase, unnecessary rejection will increase. So what to do? So this problem has been solved by the GD&T by clear-cut control frames, and showing this. If you see this, the control frame showing perpendicularity within 50 micron, 0.050 with respect to B. Here it is clearly defined. The designer wants everybody should rest the job on B surface. So there is no ambiguity here. And why designer select B? Because the job same way it is going on assembly, and same way it is going to get rest. So everybody has to follow same. The production people make the jigs fixture so that job should get rest on B and get machine. Inspection people, while checking it in CMM, they should rest the job on B. So everybody is aligned in the system. So, and everybody understood that my customer is going to use this part, or it is on the end product, the part is going to get rest on B. So that is why designer has given B as a datum. So this ambiguity has been eliminated by GD&T, and the clear-cut specification is given by this control frame. So what is the benefit of this? So because of this ambiguity is eliminated, it stops rejection of parts. It stops acceptance of not okay parts. That is also not acceptable, because the customer will get the rejected parts. Then saves time of designer, production, and engineer, and inspection. So many times in debate discussions, all the three functions become enemies of each other, and they fight each other for justifying their functional cap. And so finally you have to, the designer has to decide who is right and wrong, and production people definitely they want to save their job quality person, they have to follow their duty. They do not want other than anything, whatever written on the drawing. And drawing says 2-3 meanings. So definitely there will be chaos. This chaos by this GD&T language. This is the important part of the, so elimination of ambiguity in the is one of the important part of the GD&T. So then we go to the next benefit, wide tolerance for production within specification. So how it is possible? So let us see simple example, simple drawing. So I am just little bit explaining because many people may not be familiar with the part drawing. So this is a simple drawing. There is a hole on the plate, and hole is at position 30 plus minus 2 mm tolerance, vertically for 15 plus minus 2 mm tolerance. So basically what is the expected on these parts? All parts must on the whole position on the all parts should not cross 32 on the right side, then 28 on left side on x-axis, then 13 on the y-axis, and 17 on the y-axis. So it's a job, any center should be of any center of actual job should lie between this square, and the square size will be total tolerance horizontally, total tolerance vertically. So it will be the tolerance square zone will be 4 by 4. So this is a typical coordinate system where our traditional drawings are there, where we provide the x and y coordinates, and these x, y, and y coordinates you will get the both side tolerance, and it becomes a square tolerance zone. So any job, if you produce 1,000 plates and check this 1,000 plates for actual position of the hole, all holes should lie between this square, and the center part is a nominal 0, 0 position, and all other positions are acceptable if the your center lies in this square. So this is known as a square tolerance zone. So this is a traditional square tolerance zone. Now we'll just focus on this square tolerance zone and enlarge this. What happens here? So what happens here? If you see here, this is a square tolerance zone 4 by 4, which we have seen. Now suppose the jobs are at the corner of the square, then what happens? This is the farthest center of actual job from the nominal, that is at R. All other jobs are less than that distance, but the which is the farthest hole is which is at R. So this which is at apex of the square tolerance zone, so which is at R distance. Now if the same R and same some holes lies beyond this square but at R distance, beyond the square tolerance zone, you will reject this job because it is not lying in the square tolerance zone, that is plus minus 2 vertically, plus minus 2 horizontally. Why you are rejecting? Just because our system says I should check plus 2 minus 2 plus 2 minus 2 horizontally and vertically. But on one side, the job which is at the corner of the square, you are accepting even it is at distance R. But the same some other job which is at distance R, but out of the square, you are rejecting just because your system says you are not supposed to accept job beyond square tolerance zone. But the GD&T has closed this loophole in the system, and what they have done, they have started accepting the part which are at R distance away from the nominal. So if you see this periphery of the circle, all jobs lying on this periphery of the circle are at R distance away from the nominal, which all jobs have been started acceptable by the GD&T because those are functionally okay. Those are functionally okay because one side within square tolerance zone, you are accepting the farthest job at distance R, but on the other side, you are rejecting the job at distance R, which is beyond the square tolerance zone. So what is this? So this ambiguity and understanding, they have cleared it in GD&T, and what they have started the tolerance zone of circular instead of 4. So in our traditional drawing, the tolerance zone is 4 by 4, but now you will get a more tolerance diameter of 5.6. How it is calculated? It is a diagonal of the square. It is a diagonal of the square. So the shaded area is more than square tolerance zone. So the shaded area is almost 57% more than the square tolerance zone. So I am making a bold statement that today we are rejecting 57% parts, and those you will accept it if you follow the GD&T positional tolerance in diameter tolerance zone. So earlier position tolerance was in coordinate system as a square tolerance zone, and now we are switching over to the round tolerance zone. That will, you can enjoy the 57% more tolerance. So that is why 57% jobs you are rejecting on XY coordinate in CMM will get accepted, because many times you will find the job is rejected in metrology lab, but it is going easily on assembly. So production people are not, they definitely try it on assembly before rejecting the job. So they will find okay on assembly line, but rejected in inspection. So jobs which are in shaded area are like that. The job which are in shaded area are functionally okay, but unnecessarily getting rejected because of the coordinate system. So now it has been, instead of 4, you have got diameter 5.6 as a tolerance zone. So how it is written in the GD&T? It is written in the GD&T like position tolerance diameter 5.6 with respect to ABC. So now your all holes lie between anywhere on the circle, that is position tolerance of 5.6 instead of 4 by 4 square. So 4 by square has gone, and now the in GD&T you will enjoy the bonus, you enjoy the additional tolerance of 57% more, because earlier tolerance zone was 4 by 4, and now there is a area of circle of diameter 5.6. So this is an additional tolerance, 57% tolerance you are going to enjoy in the manufacturing. So this will save tremendously, and your per piece cost will get reduced, because today unnecessarily many jobs you are going to reject just because XY coordinate. So please always insist to the designer, go so for GD&T and the round tolerance zone wherever possible. So this is a second benefit, round tolerance zone, stop rejection of 57 parts which are functionally okay parts, and resulting reduction of per piece manufacturing cost. So now we'll go to the third, bonus tolerance beyond specification. So over and above 57%, you will get additional tolerance more than 57%. We'll see that how it is possible. So you will have to assume that simple assembly, left side is a shaft mounted on the plate, and the right side there is a hole in the plate, and it's a simple assembly going on. The plate with hole will get assembled on the plate with shaft. So what is the drawing? It's a simple drawing. There is a center distance is mentioned 120, 122, and diameter of the hole 20 to 24, and shaft is 19 to 20. But remember, the designer is always see that if you make a part as per part drawing, 2 child parts as per part drawing, at any randomly select any part 1 and part 2, it should get assembled properly. So designer is always ensure that worst case situation also part will get assembled. So what is the worst case? Worst case means maximum shaft size within specification and lowest hole size within specification. Means what? Maximum shaft size is 20 and minimum hole size is 22. So it should get assembled. That is first criteria. And second criteria is center distance also vary of hole as well as shaft should get assembled. Suppose the shaft is on right side with maximum shaft size and hole is on left side with lower side hole. It should get assembled without any fouling. That is the intent of the designer. So designer will not accept by design any rejection. So designer will see that all child parts are getting assembled, any worst case, without any fouling. That is the purpose of the drawing. And so in this case, what is the scenario? So suppose there is a hole diameter of 24, that is a maximum hole size, and instead of earlier what example we have seen, the hole is a minimum. Now suppose instead of minimum hole size, I have selected the maximum. One of the parties of hole is maximum. In such case, what will happen? There is always clearance between the assembled parts on around the shaft. So so what GD&T has done, GD&T has utilized this cushion area, which is excess clearance of this in assembly. They have utilized it for center distance. So what has been done? Even if the whole center distance is fired, that is going beyond specification. Here the center distance is 120 to 122. So there is a 2 mm tolerance. But for if they make hole of higher size, so CD, even if it get fired, rejected, the job is going to get assembled without any fouling. So see here the CD is beyond tolerance, 123 and 119. So which is, if you go by traditional inspection, you will reject this top plate for center distance. But GD&T is not rejecting these parts. GD&T is accepting this part because it is functionally okay. Because our job is in assembly is to just get an assemble and put the nut from top. That is a simple assembly. Simple it is to be clamped. It is not going to affect the performance. Of course, that is assumption. There is not affecting the performance. In such case, if it is only loose fitment, then even if the center distance is rejected, the job is getting assembled, the GD&T accept those parts because those are functionally acceptable. So this additional tolerance is called the bonus tolerance. So this is the tolerance over and above our 57% additional tolerance. So in GD&T, what happens? So GD&T, there is a control frame. So tolerance is 2 mm, which is given, but in GD&T, the tolerance is not same for center distance. It will change. Because the position. It will change based on the size of the hole. If you produce size at higher side, say 24, you will get position tolerance, additional bonus tolerance of 2 mm. So total tolerance become 4 mm. If you produce at hole at lowest size, which is MMC condition, maximum material condition, which is the smallest size of hole, which is the worst case size of the hole, you will get bonus is 0. Then you will get only 2 mm tolerance, which is given in the control plane. But if you go on increasing the hole size, if parts are more and more bigger hole size, but within specification, so you will get additional bonus tolerance. So you will get additional bonus tolerance, which will accept more and more parts, more than 57, which we have already seen because of round tolerance zone. So this is the most advantage of the GD&T. The size, you will get more and more wide tolerance if you produce the job bigger and bigger. Of course, if it is not affecting performance, designer will always ask to enjoy this bonus tolerance. Designer will provide the M condition here, then you can enjoy this bonus tolerance. But all these cases are possible wherever there is a loose fitment. Loose fitment means what? There is a threading in one and there is a bolt hole. So bolt hole clearance is always there. If bolt is of 8 mm, your bolt hole is of 10 mm. If your bolt is of 12 mm, your bolt hole is of 14 mm. So there is always bolt hole clearance, and that clearance is utilized for accepting the rejected center distance. So that is, I'm saying word rejected because rejected traditional coordinate system, but functionally okay. So that is why by GD&T it is parts are functionally okay. So this is the biggest benefit of GD&T, where you will save the parts rejecting, which are you are currently rejecting in the industry. It will get accepted. So you must insist designer should use the GD&T in their drawing. So now we'll move to the fourth benefit. Now we'll move to the fourth benefit. So this is a bonus tolerance which you get, acceptance of more number of parts which are functionally okay and resulting stoppage of rejecting useful parts. So GD&T always focus on the useful part which are functionally okay. Then now fourth is easy inspection by functional gauging. And suppose there is a M condition is defined in the drawing, your gauging becomes very easy. Because when M condition is defined means what? Designer had designed the job for worst situation. And worst situation I have explained you. Worst situation means smallest hole size, biggest shaft size assembly, and with whatever position is extreme RH side or LH side. With that, job has to get assembled. Of course, this is applicable for the loose fitment. So easy to inspection means the same job which is given that tolerance of position tolerance is 2 mm with respect to ABC. Now how we will make a gauge? Let us see. So the gauge is how it is made, because at GD&T there is a complete clarity where job will rest, where primary datum will be there, where secondary datum will be there, and where is a tertiary datum C. So the quality person job become very easy to make a gauge. How you will make a gauge? Simple plate for this checking the position of the hole. For simple plate, the checking the hole position. How the gauge is made? There is a datum, so there is a gauge plate A. Then there is a B datum where the B left side B plate on the gauge. Then C datum on the C vertical plate. So now the while inspecting job has to rest on both all three datums. That is the clarity given by the GD&T, which is not there in current coordinate system. And now what is a worst situation? Because designer has provided M condition, that is a worst situation. Worst situation I explained means smallest hole and biggest shaft should get assembled properly, even if it is shifted to the LH side or RH side within the specification. So how to design pin? So the worst situation will be what? Worst lowest hole will be 22 and this 2 mm position tolerance. So 22 minus 2. So pin size will be 20. Now what is to be done? Make a pin of 20 and put the job. If part goes inside, your job is qualified. If part doesn't go inside, the job is not qualified. As simple as that. So any casual labor can check your this job. Of course, provided there is no air gap around B, C, and A. Some simple SOP can be so used, and no need to check job on PMM or by layout method, which is a kind of time consuming inspection and costly inspection. So this is the simple gauge, and this is known as a received gauge or functional gauging. Sometimes people call functional gauging because it according to function it get checked, because the shape of the gauge will be replica of mating part. If part goes on this gauge, that means it will go on the assembly very easily. If part fouls here, definitely it is going to foul in the assembly. That is the simple concept behind the functional gauging. So this is a fourth benefit, which tremendous reduction in the inspection cost. No layout inspection. You know the layout inspection, how tedious and time consuming. And if you want to reduce time, people go for CMM, but CMM is costly. 1,000 per hour rate is there, 1,000 to 1,200. So this descaling of the inspection, making a functional gauge, you can check lakhs of parts. And of course, this is the beneficial in the production, and everybody will be happy while inspecting the job. So this is overall 4 benefits we have seen, major benefits. I have not gone in too much technical, but basically if you see, there are 14 symbols, different symbols, and every symbol has got their own property. The property, they are unique symbols. So people must understand where which symbol is to be used. Some has got datum, some are without datum, some for some we can use it M condition, for some we cannot use M condition. And recently for those who are in manufacturing industry, the one more update I have to give that in 2018 standard, the two symbols have been eliminated out of 14. That is concentricity and symmetry symbol. So there is a lot of confusion for the inspection and the intent of the and understanding the intent of the symbol. So they in 2018 standard they have eliminated these two symbols, concentricity and symmetry symbols. So that's just for information. So now this particular topic is too much technical, and we as a from on behalf of PMA, Pune Management Association, we also conduct 2 days programs on the GD&T. And in the next week itself, I had to deliver this program in one of the company in Bombay. So there is a detailed program with workshop. Actual part drawings are studied, and they are on site. And the 2 days, a lot of exercises are there on this, because this topic is too much technical, and you have to understand a lot of exercise you have to solve, and lot of variety variability is there depending on the requirement. So we do conduct this program, 2 days program, and they those who are interested can contact Pune Management Association for this particular program. And also, if question answer we can take now. And basically, those who are interested, more interested, they can solve this quiz also. I can put this link on it. Solve it. So, any questions now?
I think
Any
all
questions?
participants, in case there are any questions, you can ask it to Mr. Nandakumar Wale. Mr. Vanay Anturkar had asked a question
Yeah.
related to many customers insist increasing locating pin diameters for checking parameters under the pretext of process capability, sorry, but it rejects
Many-
okay jobs unnecessarily.
No, many suppliers, what they are doing?
No, basically they are asking increasing locating pin diameters. Whenever there is
Okay.
acceptance fixture, increase the locating pin dimension so that the accuracy will be better. But it
Yeah.
under that,
So,
I mean, increasing the process
basically-
capability, but at the same time, it rejects many of the okay jobs.
Right. So basically, we are, this is just, instead of working on process parameter, we are working on inspection. That is the
Acceptability.
issue here. So basically, instead of improving the process, we should try to produce more and more job to the nominal size by improving the process, taking actions in the process,
Yes.
instead of improving the increasing the locating bin. That is not going to help. It will get rejected.
Correct.
Many jobs will get rejected.
Correct. That is the main question what he had asked.
Yeah. We should, yeah.
So inform them that unless there is a consideration from the meeting means the total assembly, what all tolerances they allow and the reference datum as you have mentioned. Unless
Right.
all those things are considered, it is not dependent on loan. It is a part of,
Right.
I mean, it is a
Right.
total assembly which you have to consider.
Right. Yeah.
Has accepted that. Any other questions from participants? I think there is one request. What is the meaning of square for 120? The
What
drawing.
is?
I think you had shown that drawing with square 120.
So where it is shown? They can unmute. They can unmute and ask. I think 120 where it is written.
Sudesh, you can unmute and ask.
Yeah, it is given on the drawing which you just shared earlier. That is the not this one. The in the later part. Yeah. On the last. Yeah. Yeah. Go ahead. Yeah. Yeah.
120 dimension.
Yeah. So 120 is given in square in the GD&T, not on this one. It is in the square. Yeah. For example, this 121, for example.
Okay. So what is the question in this?
So the no, if this is a square, what we should interpret?
This block around the 121 square block is shown. That is why what.
Yes,
Right?
yes, yes, yes.
So in the GD&T standard, they have said that if you follow the GD&T, these dimensions are nominal dimensions. So they are either you can show it in a box or
Okay,
without box. Both
okay,
both the things are possible, but standard shows in box.
okay,
Okay. And if you don't want to use the box, you can write the note below the drawing and say about it. So because the tolerance is not shown here in the GD&T on XY dimension, tolerance is taken care of by 2 mm on the control frame.
okay,
Okay.
okay, okay. So in this case, we should not follow ISO tolerances in
Uh,
such.
no, this is the tolerance only, not 2 mm. That is the round tolerance.
Mhm.
Otherwise, you will lose benefit of 57% if you follow the again square tolerance.
Okay, okay. Thank you.
Yeah. Any other queries?
So I have put this link in the, if someone wants to just check their basic knowledge of GD&T, they can use this link.
I think your link is not visible.
No, I have put it there. Again, I have put.